walkability here. Like you say that in good faith.
The broadcast is now starting. All attendees are in listen-only mode.
Thank you everyone for joining us for our continuing webinar series, Weathering the Storm, Building Business Resilience to Climate Change. I'm Joe Casola, the Director of Science and Impacts here at C2ES, and I'm going to quickly review some of the key findings from our report, Weathering the Storm. And we're really pleased to have with us today Dr. LeChevallier from American Water, the Director of Innovation and Environmental Stewardship, and he's going to talk a bit about the work that they've been doing, which is one of the case studies that's covered in the report. The presentation will be about 30 to 40 minutes, and the concluding 15 to 20 minutes of the hour will have Q&A. There's a little chat box that all participants can type in their questions. So if questions come up during the course of the webinar, please go ahead and type them in, and I'll try to field as many as we can during the Q&A session. Very quickly, reviewing the Weathering the Storm report, we did some research about extreme weather and its impacts on businesses and what businesses are doing to prepare. And one of the key findings is, I think, something that most people, may be obvious to most on the call, but that extreme weather is very costly. In particular, in 2012, there were a number of very expensive weather-related disasters totaling over $130 billion in losses globally. A large portion of that was in the United States. Hurricane Sandy caused an estimated $65 billion worth of damage, and the drought $20 billion worth of damage. Other large events included the wildfires in the West, which also in 2011 were quite significant. And another event that we chronicle a little bit is the impact of flooding in Thailand, which really had a lot of ripple effects through supply chains associated with the automotive and electronics industries. The report, in addition to looking at what types of climate events cause a lot of problems, really tries to take the business perspective and to answer the question, well, how do businesses perceive this risk, and what are they doing to manage it, and are there opportunities that they can seize in kind of being looking down the road at some of the impacts of climate change. The report performs kind of three types of analyses. One, a review of the global S&P 100 companies, the large companies, to look at any sort of information they have publicly about climate risk and what they may be doing to manage it or seize opportunities. And this information includes carbon disclosure project surveys, SEC 10K forms, and sustainability reports. In addition, we had more in-depth case studies with 6 companies, American Water being one of them, and held a workshop at the end of November, at the end of 2012, to get companies' reactions and to hear more directly from them. And if you haven't checked out the report, we have the website here on this page. I encourage you to do so. Some of the other key findings, a lot of the companies are perceive risk as being important. 9 out of 10 out of the 100 companies that we looked at make some statements somewhere publicly that risk is from climate and extreme weather is something that they're worried about. However, a lot of them consider that risk to be managed in their normal business continuity plans. Almost 3/4 gave that response in some form or another. That a smaller portion of them are doing the kind of specific climate assessments and future climate assessments, not just current climate, but future climate assessments to think about their risk. And I think you'll see a lot from Mark's presentation that show the different types of information and the different types of assessments that represent kind of a specific investigation of climate or in the case of American Water, water vulnerability that's out there. In addition to some of the statistics of who perceives risks and what types of risks they perceive, the report also recommends this 4-step process for companies, and it's very generic, it's very high level, but I think we see this in a lot of the companies that have tackled or are trying to tackle their climate vulnerabilities. The first step is to build awareness within the company about the risks posed by extreme weather and climate change, and to communicate these kind of top to bottom. Second is to assess their specific climate vulnerabilities. Third is to come up with actual options, usually adaptation options in some way, to manage these risks, or they could be new opportunities, new markets, or new products where they may see more growth. And lastly, trying to engender some of these steps in more of a continual reassessment and evaluation over time. So that's kind of the 3-minute version of some of the details in the report. And like I said, please check out our website if you'd like to get more information. Now I'd like to turn things over to Mark, and quickly just to introduce Mark, he is the Director of Innovation and Environmental Stewardship at American Water, and his role involves the direction of the environmental compliance programs, including the development of environmental management plans for more than 1,000 operating centers, environmental audits to ensure compliance, and the implementation of environmental stewardship and greenhouse gas control programs. So I think he really covers a lot of ground at what is the biggest private water utility in the country. So with that, I will turn it over to Mark, and you'll hear from me again at close to the end of the hour.
All right, thanks, Joe. Just a little bit on American Water. We're the largest investor-owned water and wastewater utility in the United States. You can see here on the map, we operate all across the United States. And interesting from a climate standpoint there, that poses a whole variety of different risks. And I'll show you a number of examples from Superstorm Sandy to the flooding in the Midwest and tornadoes. Not only is this kind of a hypothetical or theoretical risk, this is very real for our company. We operate over 300 drinking water systems and 200 wastewater systems. We have over 1,000 wells. We also reclaim water, and we'll talk a little bit about the role of reclaimed water on climate change, and well as 2 desalination plants, and we're in the process of trying to build a 3rd. And we'll touch a little bit around desalination. A little bit of the outline of the presentation. I'll talk a little bit around climate change on water utilities and some of the severe water events, and we'll touch on some of the adaptation that's already taken place. We'll end up talking about, and I'm not sure who to attribute this to, I've heard it several different places, that in the end climate change is really water change, and that's important. I'll take a little of a side trip around mitigation, and we have some discussion whether or not this is really appropriate. But I believe for a water utility, so we're going to talk about water utilities being recipients of the effects of climate change, of drought, of flooding, yet they also have a role in contributing to that because they're large users of energy. So talk a little bit how we're managing energy and how some of that energy and that impact on water touches this water and energy nexus. Talk mostly around adaptation, on conservation, what we're doing on leak detection, but really get us down the end around integrated water resource management. And then you'll see a number of different approaches towards climate resiliency, but kind of end up with the kind of program we're having to assess our risks as a company. So this graph shows the 2 things: the average water availability in the United States, and then in the boxes are projected population growth. And you can see that in some of the areas of the highest growth rates in the Southwest and in Florida are also the areas where we're already seeing water stress. But beyond those kind of average water rainfalls, we really have to consider the variation in rainfalls. As water utilities, we have to really consider providing water services even when there's not an average year. And we've seen in these graphs, the Southwest, Texas in particular, in 2011, again in 2012, we had 60% of the the counties in the United States under drought conditions. And again, this year, this isn't just a bad year. Drought and water availability is a persistent problem for parts of the United States. And so, therefore, water utilities have to make plans on weathering the storm, as we may have to have plans that we may have to weather floods or droughts for multiple years in a row. And I was out west talking a couple weeks ago, and this graph shows the water supply availability in the Colorado River. And just in the most recent years, the water use now has exceeded the supply of the river. And as we project in the future, that water demand will continue to outstrip the availability of Western water supply. So it's becoming an increasingly urgent issue. And not just water supplies, but also this next graph shows groundwater supplies as we continue to draw groundwater reserves, particularly in the Texas and Oklahoma panhandle, but probably not realize that also in areas around the Great Lakes, Mississippi Valley, in Florida, and in lesser areas, other spots. For example, we have a number of critical aquifers in New Jersey. So groundwater supplies as well as surface water supplies are increasingly becoming challenged. And projections, this is from a study done by NRDC on the effect of climate change. That pretty much looks like Texas in the last couple of years already is experiencing what is forecast in 2050 to be the effect of climate change on water sustainability. And pretty much most of the West, again here we see surprisingly the Mississippi Valley, Texas, and all up and down the eastern seaboard in areas of increasingly water scarcity. Just in the last couple of years across American water, we have experienced a number of extreme events, from blizzards that shut down power supplies that threaten our ability to pump water, to floods, to droughts, to storms, to the windstorms. And my weather vocabulary has increased so much, from haboob to derecho windstorms to Superstorm Sandy, and we've gone from record drought and record flood in just a matter of 6 months. Stepping back a little bit more, my first experience with some of the climate change and extreme events started in 1993 when along the Mississippi River we had a treatment plant serving Alton, Illinois. That's an area just on the Illinois side, just north of St. Louis. This plant was along the river, and in '93 it was completely flooded, along with many other water utilities and wastewater systems up and down the Mississippi. Perhaps you remember Des Moines, Iowa was flooded for about a month before they got back into service. Today we have a new treatment plant that's well up on the bluffs of the Mississippi, well away from floodwaters, primarily driven by the fact that this plant was old and in need of repairs, and in fact was constrained by having a railroad on one side and the flooding river on the other. But also in more recent years, and we had an effect shown here from multiple storms. We had Hurricane Irene in August, followed by Tropical Storm Lee in September. So this affected parts of Pennsylvania and this area near Hershey, Pennsylvania. The previous record flood level was at 16 feet, and the combination of these two storms resulted in the flood levels or 10 feet higher than previous records. This picture here shows one of our pumping stations, and now how we're delivering personnel to go to work through helicopters. Now, the engineers designed this so that all the electrical equipment was up on the second floor and protected against even this flood event. The only problem is that the door to the building was down on the first floor. So luckily we had these equipment hatches that we could have access to. But certainly gives you a whole different perspective of how we might build resiliency into some of our structures. Another example in 2011 of Joplin, Missouri is one of the towns that we provide water service to. A devastating tornado, one of the worst single tornadoes in U.S. history. And you can see just leveled portions of the town. And standing back in the distance is the water tower. So some would say that that was really well-designed water assets to withstand the storm. Some would say, well, maybe it's over-designed. The key here was trying to find assets so that we could disconnect houses that are no longer connected to the water system, shut down water in the parts of the community that were affected by tornado so that we could continue to provide service in other parts. Here's an example in North Jersey during Hurricane Irene. Now this flood wall was built back in the late 1990s following Hurricane Floyd, which did flood this plant. And so it was a really good investment because there's been 5 storms since Hurricane Floyd that would have affected this plant. And you can see here with Hurricane Irene, the flood waters came just within an inch of the top of the wall. So some would say that this was really well designed exactly for flood events. But as we look at future weather challenges, we're actually looking to engineer this at the wall to be even higher. And of course, Hurricane Sandy, which impacted the United States and some of the barrier islands that we provide water service to, the ocean washed in and cut the island in multiple pieces, and not only washed out roads, water, sewer lines, everything, such that parts of the community were completely devastated. And where we used to have water services, we now have water hydrants out in the middle of the ocean. But the key to our recovery of this was our recent investment in high accuracy GIS mapping of our assets, so that we could go to a location that was covered with 3 or 4 feet of sand and accurately pinpoint exactly where that meter box was, so we could dig down and turn off the water to a house that no longer existed. It also allowed us to map the roads to allow crews to get in and begin rapid restoration of this community. And the trend that we've just talked about in the last couple years, according to NOAA, we've seen this increase in billion-dollar weather climate disasters. Joe had just alluded to last year in 2012 was $130 billion year, so capping one of the largest in recent years. But we've continued to see this trend towards increasing damage because of growth of population, because of severity of storms, because increased urbanization in areas that are affected by in climate-sensitive areas. And the forecast for this, according to the National Association of Clean Water Associations, is through 2050, another $500 billion. So with a little bit of a range here of a need for investment in climate adaptation costs for water systems, and this comes on top of already a $1 trillion forecast over the next 20 years to improve water and wastewater infrastructure, to upgrade aging facilities. So when we combine these two, tremendous pressure on water infrastructure by not only the aging assets, but the challenges posed by climate change. And of course, the key to this is through smart investment, such that the investments that we make on aging infrastructure also make the facilities more resilient to climate change. And of course, that gets us then to that idea that climate change is really water change. It's droughts, it's increased storms. It's not only melting of the ice caps and this poor polar bear hanging on for dear life, but for water systems it means shrinking snow fields, and those are reservoirs for many water systems. By having that snowpack in the mountains and the delay in melting of that, essentially is a water reservoir, and so there's changing patterns in that, leading to flooding and pollution, not only of greenhouse gases, but pollution that's related to water supplies. That's really the idea here of this next slide. One impact on climate change is some water quality changes, and even when we have water available, water quality changes may not make that water available for drinking water. For example, forecasts around algal blooms due to high nutrient runoff from storm events or reduced flow caused by droughts or higher temperatures results in blooms of algal cells. And some of these could not only create taste and odors. I have a little graph here showing an event in Virginia for a compound called MIB, methyl isobornyl. And most people can start to taste this when the levels are at 10 nanograms per liter, right down to this very bottom level. And this level, this river peaked at over 1,200 nanograms, and so it caused tremendous problems for this community. But even more of a concern would be that some of these algal cells can create toxins, and they can be neurotoxins that can affect the brain and nervous system, and toxins that affect the kidneys, hepatotoxins. And so there's increasing concern from a public health standpoint around climate change of these compounds being present in water, as well as clogging of water filters and changes in algal blooms that cause this change in organic carbon that could create disinfection byproducts that might be of health risks and growth of bacteria in water supplies. Just an example of this last idea, for a long time we've known that rainfall can affect water quality changes. This graph's a little bit hard to see, but it relates rainfall patterns to the occurrence of coliform bacteria, which are indicators of water quality and potentially contaminated water. And the rainfall data had been offset by 7 days. So the rainfall that occurred 7 days ago now have been shifted to the bacterial patterns that occur now. And you can see that in many cases, these peaks are overlapping with each other. So rainfall event 7 days ago can be traced to the occurrence of bacteria in water supplies today. The next graph here shows a change in water chemistry. This Larson index is related to changes in chemistry that can affect the corrosivity of the water. Now, this is a log scale. So a log of 1 is kind of a normal Larson index for water. We can see that some of these peaks here are related to rainfall events that, particularly in the New England area, that depress the alkalinity of the waters. When you have acid rains, it reduces the bicarbonate levels, and that causes a spike in the corrosiveness of this water. The next graph here is flood on the Mississippi, and when the river had reached flood stage, you can see a spike in the level of fecal coliforms, and these are coming from flooded upstream wastewater plants. And not only did we see increase in these fecal bacteria, but also peak levels of enteric viruses. And this last example here on the Delaware River, when we saw an increase in flow in the river, and this first flush event related to turbidity, and that's the amount of particles in the water. Also related to that first flush event is the washed of Cryptosporidium, which is an enteric pathogen, and see those levels peak along with this peak in water flow. So water quality changes and potential of overwhelming treatment barriers are a very real concern for water utilities as we see these changing water patterns. And so it's not just that the utilities are recipients of this, but water and wastewater utilities use about 4% of the nation's energy contributing to greenhouse gases. In some parts of the country, like in California, it's much higher, approaching 20%. And where do utilities use all this energy? But it's in the pumps, either pumping the treated water to your house. A family of 4 uses about 250 gallons, and at 8 pounds a gallon, that's about a ton of water that we deliver to your house every day. But also for groundwater systems, as we see dropping groundwater levels due to climate change, increase in costs in pumping. And for American Water, our carbon footprint is very much related. 91% of our greenhouse gas emissions come from our indirect emissions through use of electricity. And I just showed you over 90% of that electricity use is used in pumping. And even though we've had success in reducing our greenhouse gas emissions since our baseline in 2007, when we look at the intensity of those emissions, we still have an opportunity for improvement. When we think about our use of energy, this power equation for pumps becomes useful, where the amount of pumping power or electricity is related to the flow of water that we pump, the weight of water, the pump head or the pressure, and the efficiency of the pump. And I used to joke that we're trying to change all of these by conservation and reducing leakage, reduce the amount of water we have to pump, to change the weight of the water by dissolving helium in it and make the water lighter. That's actually a joke, but actually helium can be used as a way to look for leaking pipes. We can reduce the pressure that we pump at, and we can improve the pump efficiency. And so we've been monitoring the efficiency of our pumps. On average, they're about 65%, but you can see a number of our pumps in our inventory, in fact, have lots of opportunity to improve that efficiency by 10 to 30%. And when we look at the rate of refurbishment of pumps, we find an optimal rate of refurbishment in about the 10-year basis. So it's not only replacing our pumps, which is a long-term capital, but by being very aggressive and focusing on our day-to-day operations. Absent that kind of pump refurbishment program, we would project that our greenhouse gases would continue to grow as the pumps continue to reduce their efficiencies. But with our program around focusing on pump efficiency, we project that we can not only improve our greenhouse gas emissions on the conservation end, but by our pump efficiency end as well. And of course, we can explore alternative energy options like solar and in wind. And next year, we're going to more than double our use of wind power and bioenergy. We operate all of this, but still today, this only is about 1% of our energy portfolio. One opportunity to kind of look at where these energy and water nexus overlaps, the example here in a floating solar array that we piloted a couple years ago in New Jersey. And here we're using the area that we have for a reservoir and having on floating pontoons these solar panels. Not only do we get to be able to use this land space to capture the solar energy, but by not having the sunlight to promote algal growth can help improve water quality at the same time. So maybe certainly looking for opportunities where the intersection of these two can actually be beneficial, the intersection of the energy and climate nexus. One other thing that we're working on is on demand-side regulations with a company called Imbala from Canada, which is providing the smart grid demand management. It was a real-time, second-by-second management of the electric grid where we can speed up or slow down our pumps. The result of that pilot is shown here on the next time. So every 2 seconds, the Imbala software is interrogating the electric grid and providing a signal to our SCADA system, the computers that control our water systems, so that we can either increase or decrease our use of electricity to help provide that, that grid balance. And here it shows that most of those changes were plus or minus about 20% of our use in energy. So most of the changes are really small, resulting in probably one of the most boring graphs that I, as a researcher, have ever generated. But this just simply shows the levels of water in the storage tanks, completely seamless to the operator, whether they're increasing or decreasing the pumps to provide grid balance. For water utility operations, it was didn't even know that that was happening in the background. So, and although this doesn't necessarily in itself mean that we result in greenhouse gas emissions because we're a little shifting the energy use, it does prevent having to bring on emergency or standby energy, which may not be as efficient as your everyday power provider. Also, going back to that pump equation, one way that we can conserve energy and also provide additional water resources is focusing on leaking infrastructure. It's estimated that each day about 7 billion gallons of water leak out of pipes, of the drinking water pipes. And this represents about 16% of the total daily drinking water production. So we could have 16% more water available by focusing on leak reduction. So in 2005, we first started to pilot this technology with an acoustic monitor that in the middle of the night wakes up and listens for leaks. And here's an example of a pipe when we first start to see the pipe leaking. It was quiet the days before, and now when a pipe leaks, it makes a very characteristic sound. And we followed that leak until the point when we repaired it here at this arrow, and then the sound went back to baseline. So this system was so effective in the community we piloted in, we reduced the water loss by 50% and had a payback for the technology in 6 to 8 months. But even more importantly, we found that the pipe leaking in 60 to 75% preceded the probability that that pipe was going to break. And that's shown here. All the different pipe leaks are shown at the top. And we can see the weather events that happens, not only in the wintertime when temperatures are low, but also in the summertime when temperatures are high. We see rapid changes in water temperatures. That put stresses on the pipes that can make a leaking pipe now go into a failed pipe, a main break. Then we have to go out and fix that. We're actually now even starting to work on the next generation of acoustic monitors to give us even a greater level of ability to find and track these leakage. So one example of a technology that's not only allowing us to reduce the leakage, so we reduce the amount of water we use, but also conserve the water that we already have. Another approach around that pump equation is around pressure management. And earlier this year, we were awarded a Bird Foundation. It's an agency set up by the U.S. State Department and the Israeli government to foster technology transfer. And this was for technology, and it's kind of hard to see it on the top of this, but some electronics that when we had water that when we use less water, like in the middle of the night when everyone's asleep, most pressure in most water systems actually go up because people aren't using water. So this unit would sense that reduction in flow and actually reduce the pressure in the system. Why have so much pressure when people aren't using it? We expect that also to help reduce the amount of leakage and main breaks in the water system. And of course, conservation is another way to reduce the amount of water that we have to pump and have energy for. And so we provide, the programs are different in different states. California, our state was one of the most advanced, where we provide audits to homes and commercial buildings, rebate programs to use less water, education in the school, and public information around importance around water conservation. And we became a partner with the U.S. EPA WaterSense program to provide community education, and particularly around the Fix a Leak Week. Try saying that fast 10 times. To make customers aware that leakage in their house could result in about 20% loss of efficiency in their water supplies. And of course, one other way to drive conservation and water savings, and of course, I'm talking all of these on mitigation, but clearly they cross over on the adaptation side, because using less water makes the water that we have, particularly groundwater or reservoirs, extend their usage. And so this is not something as an investor-owned utility we can do ourselves. We have to work in concert with our public utility commissions of increasing block rates or revenue decoupling, like we have in California with a revenue adjustment mechanisms, where we decouple water from the rates and then periodically do a cost balancing account. This has been primarily implemented in gas and electric utilities, but still somewhat a novel in the water, on the water side. So let's move in about next few minutes around well, the impact of all of these effects have been a 6 to 15% reduction in water use over the last 10 years, and that's getting us in the right direction. So let's move into that discussion around adaptation, and that's really having an integrated approach to water supply. For us, it means looking at all the different water resources and matching those to the needs of the community in the best way. And those are not only investments in technologies we've shown here, and we'll talk a little bit about water reuse and stormwater capture, but also programs like we've been talking about, demand-side management, community education, and outreach programs. One good example of that here shown in New York City is an apartment building called LeChevallier, where in the basement of that building we have a wastewater treatment plant that collects all the wastewater from that plant, treats it, and uses it to recycle that water back through the building. It's designed to treat 25,000 gallons per day for toilet flushing, for makeup of the cooling water, and landscape irrigation. And of course, other approaches to water management include rainwater collection systems. But the effect of this reclaimed water system is to reduce the water footprint of this building by 50%. So using reclaimed water here is not only a benefit to the people in the building, but it's a benefit to the entire water system because they're using less drinking water, and also a benefit to the wastewater system because they're putting less wastewater into the collection system, which is a problem for New York City. We're also working with industrial clients, treating wastewater and reusing it for non-food purposes, but for cleaning and washing, potato processing, poultry, and juice and processing, where a lot of water is used to clean and wash down equipment. And reclaimed water can be used in many other applications. We have some examples where we're using it for schools, which makes a great program for education of kids, office buildings, ballparks, and you can see the list here. Obviously, golf courses, many golf courses today use reclaimed wastewater. Now, one advantage of these technologies is they can produce high-quality treated wastewater that can be used for beneficial purposes. One downside of that is the technology that uses membranes tend to be more energy intensive, and therefore we've been researching some new wastewater technologies that use less energy, and we call this NP Express. It produces nitrogen and phosphorus lower levels with less energy. And one example of a pilot system that we've had in New Jersey, this system has reduced its energy utilization by 59%, while treating the water actually better for reducing nitrogen and phosphorus, which are important nutrients that could lead to algal blooms and contamination. Not only that, but this technology results in lower greenhouse gas emissions. Some of the nitrogen that's present in conventional wastewater plants could result in producing nitrous oxide, and you probably might remember that as being laughing gas, but you know from a climate standpoint it's not a laughing matter because it's 320 times more potent greenhouse gas than CO2. Having technologies that reduce energy use and reduce nitrous oxide emissions is really a key key element for future wastewater plants. I talked about in an integrated water resource management, we have to consider all options, including desalination. So we operate a desalination plant in Tampa Bay, Florida. It uses cooling water from the nearby power plant. That helps improve the efficiency of the treatment process, but also causes some problems on fouling the membrane. And so we're actively doing some research now looking at those factors to try to make that desalination process the most efficient as possible. And while desalination in the United States is still at a very early stage, this graph here shows the same kind of, we're probably on the same kind of trajectory as was present in Israel. For many years, there were very little desalination use, and then once several plants got built, it took off, and now is a major source of water in Israel. This next graph shows here the same thing for Australia and the same kind of trajectory for Spain. So certainly in the future, an integrated water resource management program anticipates desalination to play a larger role in availability of water, particularly in coastal cities. I just have a few minutes to wrap up around our risk resiliency, and we think that risk is the likelihood and vulnerability and consequence, and our resilience is our ability to recover from those kinds of risks by managing the duration and severity. We really think about our climate resiliency, our strategy, in 4 different categories. One, about hardening assets, like example I showed you, building flood walls or having emergency power or moving plants out of the floodplains. But those are very expensive processes. Others would be diversifying facilities, having multiple sources of water, multiple treatment plants providing water to a city, so that even if one was impacted by climate change, we wouldn't lose the water supply altogether. Or having a combination of surface and ground, or desalination, like I just mentioned. Also, other asset-light solutions, like having emergency interconnections with other water systems. So even if we lost a pumping station, even a whole water treatment plant, we could get water from nearby community. One, about blind flanges, so we could immediately come up and quickly hook in emergency power, emergency interconnects, and provide water from emergency supplies and portable generators, as well as having robust emergency planning. And this has been an example in those situations I showed you, like Hurricane Sandy or Irene, when we could have a command center that's outside of the area that's affected. So you have a group of people that are not worrying about their homes washed away, but can be pre-positioning generators and gas supplies and providing that emergency coordination. So in our planning criteria, we are considering criteria around climate resiliency, and this hasn't existed in the water industry before. So what are we going to build and design plants to be able to operate under demand projections for water in floodplains, and under what kind of conditions for droughts, and with certain pieces of equipment that might be affected, that may be out of service due to the climate, or the amount of storage we have in the system, as well as standby emergency power, and even building standards that I showed you for some of our buildings. And so our process is starting to go on defining our critical assets. Many of our facilities are in areas that are environmental sensitive by its nature, into water supplies, by rivers or lakes or reservoirs, defining those critical assets into different tiers of importance, and assigning the hazard pairing to different kinds of hazards. And then using a variety of different risk analysis. I show here kind of the heat map or vulnerability analysis, determine the level of risk, and then looking at our resiliency plans develop solutions. With so many assets in American Water, this is a process that we've been developing this year. We've been doing it in the past through various engineering studies, but as we roll out this to be a much more systematic procedure. So just to wrap up, the climate change really ends up being water change for water utilities, and it proposes a number of challenges to our engineering and operations, considering a variety of different factors, both long-term and short-term imperatives. Utilities are putting assets into the ground today, expect those assets to be in service 100 years from now, so water utilities have to have that long-term look. Having rapid response to emergency weathers, and I showed you a number of different examples where we're looking at innovations on leak detection, on efficient wastewater processes, demand management with electric grids, where there's clearly opportunities for technology, for innovation and technology. So Joe, turn that back to you. We can go to our question and answer period.
Great. Thank you so much, Mark. That was a great presentation, and I think you covered just an incredible amount of material. Before I get into Q&A, I just want to remind everybody we have one more talk in our series, and it is December 4th. It will be covering the Rio Tinto case study. And this link here actually gives information for all our webinars, including the presentations, and this presentation will be posted as well. So first, I wanted to ask Mark, you identified all of these, what I think are great kind of win-win-win solutions, areas where there is a monetary savings, a reduction in greenhouse gases, and, bolstering of resilience. And it may be through demand side management, it may be through better monitoring of pressure, it may be through different pumping, technologies and efficiencies. How has American Water kind of identified these areas and explored them? Has it come from kind of the facilities and engineering folks kind of up the chain? Has it been at the risk management kind of putting an incentive and kind of communicating that kind of down through the organization? Can you talk a little bit about the process of how these have been kind of identified and implemented?
Yeah, certainly. It's a collaborative, and we're getting input from across that spectrum. We developed several years ago an innovation development program where we're specifically looking for technologies that may be on the fringe or outside the water industry and bringing those in. And so given our size and footprint, we can be a validation shop for those technologies, and then we can help market those. We can help our innovator, communicate the benefit of those technologies to the rest of the water industry. So technology like Mbala, the pressure management have kind of come through our innovation program. Also part of it is our research program. American Water, for more than 30 years, have had a formal research program on water. So some of the things around, making, improving the efficiency of the desalination membrane, some research on algal blooms, some of the technologies on leak detection have come from our research program. But also our engineering program, it does typically a 5-year and a 20-year capital program. So we're looking at each individual facility as far as their capital needs. And part of that capital planning, engineering planning, is looking at, the resiliency, concerns around resiliency for those facilities from climate change. As well as, past experience. We had Hurricane Floyd that flooded the system, so invested in a flood wall, and that's paid off in 5 storms since then. So certainly input from operations. We just completed this month another flood wall for facilities along the Mississippi River. Certainly that will come in handy in the future. So it's the entire organization having to provide input to things that are critical to the future of the business.
Excellent, and that seems like something that would be a hallmark of a thriving business, just kind of in general, that kind of across the board contribution to strategic priority. I wanted to shift gears and talk about policy, and you had mentioned very quickly some of the decoupling policies that are in effect in different states. And I was wondering if you could explain a little bit more about that, because I think for folks like me from a more climate background, that type of policy, they may be less familiar with it. And how is it that a utility, maybe in the context of utility, you got to sell water to people, or the service of water, how you can also be so in favor of actually reducing demands out among your customers.
Right, and it is a catch-22, because as a utility we sell water, but in fact the water falls from the sky. And I mean out west you can actually own the water, but along the East Coast, water is owned by the state, and we get a right to use it to benefit our customers, but we don't actually own it. What we're really providing is the pressure and the purity of the water. You're free to go down to the river and get your own bucket of water. You can haul it home. Like I said, if you do, you'll be trucking home a ton of water each day. So we really provide a service, and yet that service is linked to to something we really don't pay for, which is the water. And that's a discussion we have ongoing with with all the variety of different public utility commissions that we operate in all those states. And in some states, California is very advanced, and they see that and see the benefit of decoupling that, because it's while customers pay for the service through the water, really it's not really the cost of water, it's all the infrastructure and planning goes into delivering that water. So it's an ongoing discussion, and we constantly bringing to our public utility commissions the declining use and the impact that it has on rates, and how it really is in our customers' interest that we could be promoting conservation and resiliency, and yet in doing so just continue to drive pressure on water rates. So it's an ongoing discussion we have, part of our strategy, engaging every one of our public utility commissions.
Great. We got one specific question on desalinization, and wondering if you could talk a little bit about how that technology kind of compares to in cost. I know that years ago that desalinization was something that was so expensive that, especially from an energetic standpoint, that it was hard to deploy. Has that technology changed, and what are kind of the prospects for it going forward?
Yes, well, desalination has become more energy efficient with energy recovery, with membranes that are more effective at removing the salt at lower pressure, and future and the potential for future technologies as we get into some of the nanotechnologies around membrane configuration. But even today, it still is more expensive than available water. But when all the available water is gone, the next drop of water will cost a lot more. And so in that hierarchy, certainly, using the available surface and groundwater will be cheaper. But when those are being overdrawn and impacting, the ecology of the water systems, or overdrawing the groundwater, so that you have some areas the ground level has dropped because of overpumping the aquifers, one has to come to a balance and look at that integrated approach. Treatment of wastewater for reuse is a growing trend. We're seeing that being done in California and San Diego, and it's already being used, treated at a high level, and used for drinking water supply in some parts of Texas. We'll see that grow. But that uses a technology that isn't too much different than desalination alone. It uses usually multiple membrane reverse osmosis. So when you start to look at the cost of the next drop of available water, whether it's reuse or desal or developing other water supply catchment areas, it starts to be cost competitive, and so it certainly needs to be in the portfolio that utilities look at in making responsible decisions for their communities. It's interesting, and that one study by the National Academy of Science projected in 2050 that most of the coastal communities will have their water from desalination. Now, I don't know if that's true or not, but if you follow that projection from Israel and Australia and Spain, it may not be out of the realm of possibility that we won't be relying on surface or groundwaters for drinking. They'll come from desalination, because we have to balance that with the ecological impacts, and then didn't even talk about food security. So we're going to get water for irrigation, for food supplies, as well as energy security.
Yeah, that broadening not just the energy-water nexus, but kind of the energy-water-food-land, multiple intersections of Venn diagrams. Just one last question. When engaging in these efforts to update the technology in your system or change the operations, to what extent have partnerships in the different local communities or states or even with federal agencies, what role have they played? And it could be with civic organizations, with academic or research organizations, you mentioned some of the regulatory folks, could be with the energy providers that you work with the other types of utilities. What types of partnerships have really played a role, and what types of things has American Water kind of gained from those partnerships?
Yeah, I mean, I think we try to give examples of all kinds of partnerships, even international partners looking for technologies in other countries that may have, parts that are, some challenges that they already have met, like I talked about that pressure technology from Israel. We really find a lot of value. We can't be in this alone. We provide water as a service to the community, so most definitely means engagement with our customers, with other stakeholders, politicians. We're users on a watershed, so it means engagement in water use and water protection within a watershed. When it comes down to environmental regulations and long-term public policy with economic regulators, it requires many stakeholders and a variety of different levels of dialogue. And at the end of the day, water's so critical to, not only our lives, but the economic prosperity of our community. So it's an important dialogue, and one that has been fruitful, and certainly one that is growing in the level of interest. And when it comes to talking about drinking water, everybody's interested in it because it's something that you touch every day, and so there's kind of an inherent human interest in water, and so those partnerships have been very, very valuable. That really is the cornerstone of our integrated water resource management, is to engage in a whole range of different stakeholders and partnerships. It's the only way we're going to get this done.
Great. Well, thank you for answering all those questions, and I'm sorry to those who wrote in questions that I didn't get a chance to get to. But if there's a way that we can help you get answers offline, please let us know. Mark, thank you again for giving a whirlwind of a presentation to get a look inside some of the technologies, decision-making processes, risk assessment, and all sorts of policies, all sorts of work that American Water is doing to build their resilience and to reduce their greenhouse gas emissions. And thanks again to all the people who stayed on for the webinar. Please let us know if you have any questions, and join us again on December 4th. We'll see you real soon, and thanks everybody for participating.